Hello everyone, welcome to today's video on mathematical induction. So we want to use the method of mathematical induction to prove that if n is a positive integer, then this is correct and this other one is an integer multiple of 8. So let's start already. So this is the function that we want to prove. So if we say p of n is equal to the first one, p of 1, in this of course it's a polynomial, it's 1 into 1 plus 1 into 2 times 1 plus 1 all over 6. You have 2 times 3 times 1, 2 times 3 times 1, 6 over 6, which is 1. So it is true. This one is true. Let's do for the second one, which is p of 2. Is now we put 2 anywhere we see n, we put 2. So it will be 2 into 2 plus 1, 2 times 2 plus 1 all over 6, and that's if you like 3 times 2 6, that's 2 times 3 times 5 all over 6, so it's equal to 5. So that if we add these two, and it's equal to 1 squared plus 2 squared, which is equal to 1 plus 4, which is equal to 5. So it is also true. It is also true. Of course, this one is 1 squared and it's equal to 1 for the first one. So for this third one, let us quickly do it to confirm. For the third one, P3, we will have that 1 squared plus 2 squared plus 3 squared should be able to give us, okay, let's say 1 squared 1, 2 squared 2, 4, 3 squared 9, that's 14, I think. So if we put it in that, we will have 3 into 3 plus 1 into 2 times 3 plus 1 all over 6. So we have it to be, this is 3 times 4 times this is 6, 7 and 7 all over 6. So this one 2, so it's 14. So it's also true. It's also true. So that means that we can assume that our p of k, if we put k there as any number k, we can assume that is equal to 1 squared plus 2 squared plus 3 squared plus dash dash plus k squared will give us k into k plus 1 into 2k plus 1 over 6. That should be true. We assume it to be true. So, but in order to prove it, we'll also say, let us put 1, add 1 in k. K plus 1 will give us 1 squared plus 2 squared plus 3 squared plus dash dash plus k squared plus k plus 1 squared will give us this value plus k plus 1 squared. It will give us k into k plus 1 into 2k plus 1 all over 6 plus k plus 1 squared. So that's what it should give us. So we come here immediately. If we find the LCM of this, if we find the LCM of that, we will have, of course, it will be equal to k into k plus 1, 2k plus 1 plus 6 into k plus 1 squared all over 6. That's what it will give us. So we can factor out 1k. Can factor out 1k. If we bring out this one and this one, we'll have a k plus 1 into k into 2k plus 1 plus 6k plus 1. That's what we will have. all over 6. So now we can multiply out. This one. If we multiply it out, we will have k plus 1 into 2k squared, 2k squared plus k plus 6k plus 6 plus 6k plus 6 plus 6k plus 6. Okay, so this we can factorize all over 6 if you like. We can factorize this because this is 7k. This whole stuff here is 7k. Let me now write it in another place. Let me just put 7k there. 7k. So if we multiply this and this, we will have a 12k squared. So we want two factors that when multiplied will give us 12k and when added will give us 7k. So it is 4k and 3k. 4k and 3k. So we will now rearrange this equation to look like k plus 1 into 2k squared plus 4k plus 3k plus 6 all over 6. So that if we now factorize, we will have that k, let me just put 1 over 6 here instead of occupying space. K plus 1 into this one will give us a 2k outside into k plus 2 then k plus 2, this is 3 plus 3 so that's what we will have, plus 3. So that the main thing will now be 1 over 6 k plus 1 into 2k plus 3 into k plus, there's the common factor, k plus 2. So this and this, then this and this are similar. So that's what we will have. So from here you will see that it looks like that our equation when we put it in k plus 1. You see that it is k plus 1 into k plus 1 into k plus 1, if you like, plus 1 into 2 into k plus 1 plus 1 all over 6. So you see that it's proven, it's true. So this is true and it has been proved. It has been proven. It's true and it has been proven. Let's see if we can do the second one with the little time we have. So we want to get this. So in order to get this, we say that let L and M be a member of a natural number, so that L is an integer. If L is an integer multiple of 8, where it's an integer multiple of 8, if and only if there exists a number Q such that L is equal to QM, so that the number is equal to QM, so that when we will now put P of 1 into that, we will have 7 raised to the power 2 times 1 plus 1 plus 1. So and we see that it is equal to 344, and 344 is nothing but 43 times 8. 43 times 8. 43 times 8. So if we do for the second one, P of 2, we will have that 7 raised to power 2 times 2 plus 1 plus 1, and it's equal to 16808, and this 16888 is equal to 8 times, is equal to 2101 roughly times 8 times 8. That's what it is equal to, times 8. So we now assume that the P of our K is true, and if that is true, that will be 7 raised to power 2k plus 1 plus 1 is an integer multiple of 8. It's an integer multiple of 8. So if that is an integer multiple of 8, that means we can say it's equal to 8m. 8m. It's an integer multiple of 8. So we now want to do for P into K plus 1. If we do for P into K plus 1, so we are going to, anywhere we see n, we put K plus 1. K plus 1 plus 1 plus 1, then plus 1. So that if we open up here, if we open it up, we have is equal to 7 2k plus 2 plus 1 plus 1. That's what we will have. So but we can arrange it to look like what we have before, plus 1 plus 2 plus 2, so that it looks like this one. So plus 1 plus 1. So that if we now substitute this here, what you see that we have 7 raised to power 2, because this multiplication law of indices, 7 raised to power 2 is 7 times 7, that's 49. We have is equal to 49 into 7 raised to power 2k plus 1, then plus 1 plus 1. So but from here you can see that this 7 raised to power 2k plus 1 is just 8m minus 1. So we can put it there. It's 8m minus 1. This thing here, look at it here. Look at it. So 8m minus 1 will give you that plus 1. So that if we open it up, we'll have 49 times this is 392m minus 49 plus 1, and that is 392m minus 48. So that if we factorize by 8, we will have 49m minus 6 minus 6. So you see that 7 P of K plus 1 is also a multiple of 8, just like we have assumed that this is also a multiple of 8. Thanks. That is how to do this. Please subscribe and click the notification button so that whenever we post the new video, you will see it. Enjoy. Bye.